Hi everyone! It is my honor to present our work, The Impact of Navigation Aids on Search Performance and Object Recall in Wide Area Augmented Reality. I am You-Jin Kim, a PhD candidate at UC Santa Barbara. I had the honor to work with Radha Kumaran, Ann Milner, Tom Bullock, Barry Giesbrecht, and Tobias Höllerer for this project. Here's the outline of our presentation, and I would like to move on to our introduction, including our objectives and an overview of the experiment. In this paper, we evaluate and compare 3 different augmented reality navigation aids in a wide area, outdoor, user study with 24 participants. We also assess situational awareness of different objects in the environment. We had 1 inward navigational aid and 2 2D navigation aids. Figure A shows inward 3D arrows. Figure B shows the on-screen radar. Figure C shows the on-screen horizontal compass. In the early days of augmented reality, there were several technical challenges to overcome, particularly regarding tracking and rendering in large outdoor spaces. As research advances, headsets that are truly untethered and allow users to freely experience AR in the outdoor will become available, allowing the everyday AR. In recent years, navigation and search aids, particularly for people with low vision or limited accessibility, have been explored through visual cues, word markers, and haptic feedbacks. Some projects have focused on locating targets outside of field of view. These work have paved the way for our experiment and encouraged us to conduct a study of navigational AR aids in a wide area outdoor environment. In this experiment, participants were asked to find all the targets, which in this experiment were word-stabilized virtual green gems, while performing a dual audio response task. Users completed a training module prior to the experiment and also did a practice trial to familiarize themselves with each of the navigation aids. Here you see 3 navigational aids we tested, and we will explain more in our design section of the presentation. Here you see a first-person point of view of a user using the inward arrows. Tracking appears much more jittery in this video example than in real life because of the additional load induced by Microsoft's mixed reality capture on a system that was carefully performance optimized for the trial. 3 navigational aids were evaluated: inward arrow vertically above each gem, an on-screen radar with a forward-up design and gems indicated by hollow green hexagons, and an on-screen horizontal compass with green hexagons above the line indicating gems in front of the user and distance to each gem above the hexagon. I would now like to invite my colleague, Radha Kumaran, to present the rest of this talk.
Thank you, You-Jin. In this section of the talk, we will break down the design parameters of the experiment. The experiment consisted of 3 tasks. The main task, gem search, was accompanied by an audio response task, both used to assess the impact of navigation aid on search performance and behavior. After all the trials were completed, we administered an object recall task that users were not alerted to beforehand to assess the difference in user awareness of physical and virtual objects in the environment. In the gem search task, participants found and classified as many of the 24 gems as they could in 10 minutes. We studied 2 independent variables in this task, navigation aid and bin. Bin refers to 4 sections of the experiment trial based on the number of gems found, first 6 gems, second 6, and so on, and was introduced to understand order effects through the trial, since the search task becomes harder with a decreasing number of remaining targets in the scene. We measured a number of dependent variables, including time taken to complete the task, speed of walking, and head rotation. The next task was the audio response task, which required participants to listen to a stream of words and respond to each occurrence of their assigned target word. Navigation aid again was our independent variable, and we measured response accuracy and response time as dependent variables. In the object recall task, participants were tested on their recall of the environment by classifying objects into one of 4 categories: real, virtual, present in both real and virtual forms, and not present. We will now discuss some key insights from our analysis of study results, including benefits and potential side effects of the tested augmented reality navigation aids. First, the presence of AR navigation aids altered performance in the search task. Participants took significantly longer to complete a trial with no aid compared to any of the 3 aid conditions, with these differences mostly driven by activity during the last bin, when the search for remaining targets got harder. Among the 3 aids, there was some benefit of the arrows in the earlier bins, but this did not extend to the final bin, where participants needed to scan the environment to discover remaining arrows and targets. There was increased head rotation in the arrows condition compared to the other 2 aids, which could be indicative of a less focused search pattern with the in-world arrows. Participants also walked faster in the arrows condition compared to the other aids. The reduced walking speed with the on-screen aids could be due to the need to spatialize 2D information from the aids in 3D space, as well as reduced attention to the 3D environment. Next, there was strong user preference for the arrows over all other conditions, which tracked with the reduced search time in the earlier bins of the trial. Between the 2 on-screen aids, there was a trend to user preference for the compass over the radar, but no conclusive evidence one way or another. We also discovered some potential side effects of augmented reality use. Situational awareness of the physical environment was found to be impacted, as there was significantly reduced recall for real objects compared to all other object categories. This suggests a shift in attention from the physical world to the virtual annotations. User accuracy in the audio response task was numerically higher, but not significantly so, with no aid than with the presence of an aid. And this was accompanied by a significantly faster response time with no aid when compared to the compass. This suggests that there is a cognitive cost associated with the use of the compass in augmented reality that can negatively impact multitasking ability. We also recorded eye gaze for the entire duration of each trial, and this figure shows heat maps of the gaze for each navigation aid. There is a clear focus on the compass and radar areas of interest in the 2 conditions respectively, and this is supported by significantly higher gaze density in each area of interest during the task for the 2 conditions. Reduced screen coverage in the compass condition compared to no aid, and significantly fewer gaze samples outside the virtual field of view with compass and radar when compared to no aid, suggest that on-screen aids might reduce awareness of the real world. In conclusion, we present a wide area outdoor augmented reality user study that compares different on-screen and in-world AR navigation aids in a gem search task. Many real-world scenarios involve people searching within their surrounding environments, and we demonstrate that AR annotations, both on-screen and in-world, can successfully support such search tasks with reduced search time when using augmented navigation aids. Although there was a strong user preference for the in-world arrows over on-screen aids, the overall results suggest that there may well still be a place and time for on-screen navigation aids such as the compass and radar, given that in-world navigation aids require very precise tracking capabilities. There was also a small trend towards better performance and preference of the compass over the radar, but no conclusive evidence one way or another. We found evidence for reduced situational awareness of the physical environment compared to the virtual annotations, which could have important implications for the design of augmented reality applications for wide area use, such as the need to emphasize important physical infrastructure in AR applications and the value of an AR environment with minimal visual clutter. Thank you for taking the time to listen to this talk.